All right, what we have here is we're going to find how to solve a limit using the conjugate technique. What we have here is we have a limit. We're going to find x approaches 4. And the first step we always want to do is we're going to use direct substitution. All right, direct substitution, it can only be used when we have a function which is continuous at the c value. In this case, our c value is 4. So to find out if this is continuous, what we're going to do is we're going to actually substitute 4 into all the values. When we do that, we're going to have the square root of 4 plus 5 minus 3 over this 4 minus 4, which we realize is going to be the square root of 9 minus 3 over 0, which this turns to be 0 over 0. Now, 0 over 0 is what we refer to as indeterminate form, okay? Indeterminate form again. Indeterminate form. And generally, with indeterminate form, is that this tells us at c, so at x equaling 4, generally, there is what we call removable discontinuity. Removable discontinuity. Now, removable discontinuity means that we have a hole in the graph. There's a one undefined value at 0, 0. Now, since there's a hole in removable discontinuity, that means that we can still find a limit because the value is approaching the same value from both sides. Okay? It just means that the value is not defined there, but there still may be a limit because limits are not the actual value of a function. It's what's happening as you get closer and closer to this. Now, in this problem, I've talked about dividing out, all right, and when we have a common factor or whatever, and there might be some dividing out here eventually. But before we do that, we notice that we have a square root. Whenever you have a square root of a function, this is very common, is that we're going to use a technique which is called the conjugate technique. Okay? The conjugate technique is going to be using this to simplify this expression, all right, to find a complementary expression which is equivalent to that everywhere except that when x equals 4, okay? And that's our c value. So to do this, we're going to take the square root of x plus 5 minus 3 over x minus 4, and we're going to multiply the top and bottom by the conjugate of this expression. Then the conjugate of wherever the square root expression is. So we're going to multiply the top and bottom by that. Now, the reason why we're doing this is so we can eliminate, all right, the square root and eliminate this hole. So when we do this, what we're going to have is we multiply these two together. The square root is going to have x plus 5. We're going to have the middle terms, because they're conjugates, will cancel out. And then we have negative 3 times 3, which is negative 9. Now on the bottom, we do not need to FOIL this through. Do not FOIL it through, I would recommend. Because when you do, bad things will happen, because there will be something that will divide out, that will factor out pretty nicely in the end. Now when we continue this, what we notice is that we have x minus 4. Well, you happen to see that there's an x minus 4 on the bottom of this as well. So we're going to take that x minus 4, and we're going to cancel it out. What we're left with is an equivalent expression from the top, and we eliminated the whole when x are at 4. How do we know that? Well, now, since we canceled this out, we left our 0 over 0, it's gone. So we eliminated the whole, and now we created a continuous function at 4. To find this, we're going to use direct substitution again, called ds. We're going to plug in 4 into this expression. So we have 4 plus 5 plus 3, which is going to be 1 over 6, and that's our limit. All right, we're going to have another example of how to use conjugate technique in another tutorial, but this is a very common, all right, equation that you would see, or function you would see, where you're trying to find a limit at a hole, all right, where you have indeterminate form, and where we can't use direct substitution, but instead we're going to use what's called the conjugate technique. And we always multiply the top and bottom numerator and denominator by the conjugate of whatever that root expression is. So good luck, God bless, on the rest of your problems.